The European Board for Atomic Research, CERN, known for its remarkable work in molecular physics, is at the forefront of scientific progress. The renowned Molecular Physics Lab recently shared an extremely rare discovery from its Large Hadron Collider, LHC, that could entirely change our understanding of the universe. Researchers believe these strange revelations could imply the existence of alien life in an alternate reality. Experts are excited and discussing this groundbreaking idea. If proven true, what profound insights could it offer into the nature of reality? Let's explore the new research just released and see why scientists at CERN are finally taking a stand against this unsettling new discovery that could change everything we know. CERN stands for the European Organization for Nuclear Research. Since its founding in the early 1950s, the organization has been known for its bold experiments. It has often made headlines for controversial reasons. Its tests have raised concerns about the creation of black holes in our world and other potential dangers. The construction of the Large Hadron Collider, LHC, is one of CERN's most famous and contentious projects. The LHC is the largest particle accelerator on the planet. It became operational on September 10, 2008, and is still the newest piece of CERN's accelerator complex. It consists of over 27 kilometers of superconducting magnets and a set of devices that accelerate particles as they travel through it. The cost of building this marvel exceeded $4.5 billion. Many would say the money was well spent, as the LHC has led to some of the most significant discoveries in recent years, such as the discovery of the Higgs boson and many other previously unknown particles. Particles can be accelerated around the LHC ring until they reach near-light speeds, completing more than 11,000 laps per second. A set of powerful electromagnets within the LHC create a magnetic field that is nearly 100,000 times stronger than the Earth's magnetic field. Some people are concerned about what might happen to local technology and the Earth's magnetic field when such a strong field is generated. When these particles reach their maximum speed, 99.999999% the speed of light, the particles traveling in opposite directions collide with tremendous force, releasing vast amounts of energy and a variety of particles. When particles collide, they release a burst of new particles, most of which exist for only a fraction of a second before disappearing. Scientists can detect new particles by adjusting the particle sources. Ultra-sensitive detectors, specially designed for these collisions, are placed around the collision sites to capture all the data from each event. It takes a significant amount of time and effort to sift through this rapidly growing data. The LHC generates more than 15 petabytes of raw data every year. Researchers must carefully sort through this information to find the data they need. The LHC reached a major milestone in 2017 when it stored over 200 petabytes of data permanently in its tape libraries. To give you an idea of how much data this is, 1 petabyte is about 250,000 movies. But what are they really looking for in all of this data? They discovered that a specific type of quark was behaving unusually. Physicists say that quarks come in different types because they are the building blocks of matter. Some of these types are unstable and decay into other particles very quickly. Researchers were interested in the beauty quark because it had an unusual decay pattern that didn't match predictions based on the standard model. The beauty quark typically has a lifetime of 1.2 trillionths of a second. They expect that when a beauty quark decays, it will be affected by the weak force and transform into a group of lighter particles called leptons, one of which will be either an electron or a muon, with an equal chance of either. However, the LHC data showed that these quarks only turned into muons 70% of the time. The other 30% of the time, they turned into electrons. This difference could exist if a type of particle that has never been seen before is involved. Because of this, some scientists believe a new kind of physics might be at work. A new particle carrying force could mean a whole new area of physics that could contribute to the current model and help resolve many outstanding issues. The Standard Model theory explains most of what we know about the building blocks of the physical world. The Standard Model is a scientific theory that perfectly explains everything we know about the structure of matter. To make things even more astonishing, researchers know that this model is still incomplete, even though it is highly accurate. The electromagnetic force, the strong force, and the weak force are the only forces that the standard model currently accounts for. Neither gravity nor dark matter, which makes up much of the universe's mass, can be described or explained by the standard model. Scientists found an anomaly in the data that was not consistent with what is understood in the traditional framework. Because the LHC generates so much data, it is not uncommon to find results that don't fit into the usual framework. However, this time, something grabbed the researchers' attention, and they realized they needed to do more research to figure out what this new event might be. This brand new force could one day explain the unusual discovery. Scientists propose that there may be a new fundamental particle, which they are calling Z prime, that carries force. They think this force would interact differently with electrons and muons, but for now, they don't know how strong its interactions are with standard model particles. This force is probably very weak because there have been no indications of it so far. If scientists find new particles that carry force, it would be the biggest breakthrough in physics. Material science in 10 years. Physicists think that, assuming this view is demonstrated as genuine, it will assist with tackling well-established mysteries of the universe and appear to be legit answers to old questions, like what dark matter is and what the Higgs boson does. Now, some researchers feel that this unseen power could assist physics in reaching one of its most significant objectives in the last 100 years, uniting the entirety of the fundamental forces of nature. This is what Elon Musk has to say. Between 1998 and 2008, CERN assembled the Large Hadron Collider, LHC, which is the biggest and most powerful atom smasher made. This process was helped by over 10,000 researchers from more than 100 different nations and many schools and labs. It is about 175 meters underground and is in a 27 kilometers long tunnel that runs through the line between France and Switzerland near Geneva. Not only that, but in the Large Hadron Collider's first crash, the energy of each beam was 3.5 tera-electron volts, which is about multiple times the previous world record. When the LHC was made much more powerful, the energy hit 6.5 tera-electron volts per beam. Musk said that proton beam influences are what the Large Hadron Collider does best. Another thing it can do is speed up lead-ion beams. The collisions between protons and lead usually occur for 1 month every year. It is the principal objective of researchers to test the predictions of several particle physics theories with the Large Hadron Collider. It is important to remember that researchers are testing the Higgs boson's properties and searching for the huge group of new particles that subatomic particle theories say should exist. In the same way that the electromagnetic force holds atoms and molecules together, hadrons are comprised of quarks that are kept intact by a strong force. Neutrons and protons are two examples that most people understand. The pion and kaon mesons are among them. They were first discovered in experiments with cosmic rays in the late 1940s and early 1950s. It is possible for two light ions that are in conflict with each other to meet at the LHC. The Higgs boson is believed to be an essential particle connected to the Higgs field. It's the quantum movement of this field, which is like looking at waves in the water. The boson is like a pristine zoo creature. In other words, it doesn't have the quantum properties of essential matter or the carriers of quantum interaction actions like the weak force, electromagnetic force, or nuclear interactions. The Higgs boson was found at the Large Hadron Collider. This was a major discovery that was made simultaneously by the two biggest multi-purpose experiments, ATLAS and CMS. It was disclosed at CERN on July 4, 2012. It was first seen in two extremely rare decay channels that gave the clearest signal: decay into a pair of photons, which required a completely quantum virtual interaction, and direct decay into pairs of Z bosons, which are the carriers of the neutral-weak interaction. At the time, the discovery of the Higgs boson set the standard model. However, researchers continued searching for this elusive particle. The confirmation of Higgs decay was one of the most significant discoveries since 2012. At that time, CERN said that more studies would be done on this elusive particle during the LHC's third cycle, especially after the high luminosity upgrade is done in 2029. This will make it possible for the LHC to have more collisions, which will give researchers a better chance to find strange physics-like events that don't fit into the standard model. CERN believes that the accelerator will make 15 million of these particles every second when it is reconstructed. This is similar to how the LHC produced 3 million Higgs bosons in 2017. This could help us sort out the various types of Higgs boson theories that go beyond the standard model of particle physics. It's predicted that there could actually be 5 different kinds of Higgs bosons, some of which may not be made as frequently as the fundamental Higgs. Researchers have strong evidence for an attractive Higgs boson, even before the changes. Why does this matter? In the early minutes after the universe was created, the Higgs field was vital and fundamental. It tells us precisely what kind of void there is in our spacetime. We know that it makes matter and interactions possible, as well as how all known fundamental particles get their mass. Without the Higgs field and the Higgs boson, there would be no chemical elements, stars, or life in the universe. What is your take on the name God particle for the Higgs boson? After it was found, the Higgs boson was given the name that's God particle by the media. Most people believe that the term came from Leon Lederman, a Nobel Prize-winning scientist, who angrily called the Higgs boson the goddamn particle because it was so elusive. According to Business Insider, Lederman wanted the title of his book about the Higgs boson to be The Goddamn Particle, but the publishers disagreed, so they changed it to The God Particle. This sparked a debate among physicists about the particle and religion that continues to this day. Still, it's hard to exaggerate how significant the Higgs boson and field are. According to this theory, only particles would have mass, which means there would be no stars, planets, or people, which might help explain its bizarre name. Researchers are still studying the Higgs boson for 2 reasons. First, they need to understand how the empty space we live in came to be in the early universe. Second, they need to understand how to keep this empty space stable. The Higgs field is unique because it sends mean vacuum potential energy that isn't zero to the actual vacuum. Normally, this is what makes our universe unique. Researchers believe that the electromagnetic force, which has an infinite range, and the weak force, which has a tiny range, are caused by changing the form of the energy potential so that they would be able to do this. To study this, researchers need to create sets of Higgs bosons and examine how these bosons interact with each other. Since the answer to the significant question of how all remaining essential particles get their mass was helped by the Higgs boson, we still don't know what its mass is. However, any imbalance in the theory doesn't protect this mass and makes it unstable, which would lead to changes in quantum mechanics that could make the vacuum itself less stable. Researchers are still searching for additional Higgs boson-like particles that would indicate the presence of new physics required to stabilize the Higgs boson mass. Fortunately, these timescales are much longer than the known lifetime of the universe. These factors make it more crucial to study more information and, if possible, gain access to more collider energy. That is why, after 10 years, many specialists from around the world are still working on the project. The Higgs boson was first thought of in 1964 and was finally found in 2012. People who are interested in science have asked why it took such a long time. This is because the Higgs boson is extremely heavy and extremely delicate. Researchers needed to concentrate a lot of energy into a small space to create such a massive particle. They required a collision with a lot of energy. Higgs particles decay in a variety of ways after they are created, and only a small number can be singled out from the noise they create. The biggest and trickiest devices are needed to detect these particles, then to find a Higgs boson signal. They looked at billions of collisions between protons. But will the efforts and outcomes of CERN help us discover big things? What will happen to us eventually? There are 3 primary conspiracy theories about what CERN is doing. Some people have blamed CERN for the worst ideas, including that the organization is trying to open a gateway to hell. Some people feel that CERN's tests with subatomic particles going at the speed of light will assist individuals with getting to the opposite side of the last fire. CERN, on the other hand, says that making antimatter is a method for looking into issue and mass. As indicated by Wikipedia, antimatter is comprised of subatomic particles that have the negative electric charge of matter. Individuals who believe in the Big Bang Theory think that antimatter formed when the world first began and should be addressed similarly to matter. However, antimatter isn't found regularly. The Mandela effect is the focus of the second CERN plot theory. The Mandela effect is when many people remember something from the past differently from how it truly occurred. Certain individuals who believe in conspiracies think that CERN's particle studies will cause major changes in our world and send Earth into an alternate world, which would have a meaningful impact on a large scale. Finally, some people who believe in conspiracies think that human sacrifices occur at the CERN building. In 2016, a video was said to have been shared online that showed ritual sacrifices occurring at CERN. The video was said to show several people in hoods walking around the CERN grounds. People thought the tape showed individuals in masks stabbing a young girl in the chest. The CERN spokesperson quickly killed the story, saying the ritual was actually part of a big joke. There is still no response to whether a police investigation occurred after that. It's not surprising that CERN has been the subject of scheme theories for a long time, so it shouldn't have been a shock that conspiracy theories would start to spread online on July 5, 2022, when researchers finally started working again after 3 years of repairs and upgrades. Although this news may frustrate science buffs, it is clear that CERN does not want to build a gateway to hell, the future, or some other world. Proton beams continue to dash around the 27-kilometer circle of the world's largest particle collider, which is more than 300 feet beneath. Ghost particles have been found, and its ability to smash particles together at extremely high energies has allowed scientists to see into the farthest reaches of material science for almost 10 years. The LHC's Forward Search Analyze indicator has found something startling. It has recognized 153 neutrino interactions with great precision, marking the first time high-energy neutrinos created by a particle collider have been found. Researchers might have the opportunity to learn more about the universe's major areas of strong neutrino interactions and how stars consume up and detonate into cosmic explosions. By reaching this significant milestone in particle physics, neutrinos are very tiny subatomic particles that can be found everywhere. Neutrinos are made when nuclear cores come together or break apart, radioactive decay in Earth's particle accelerators and nuclear reactors, and even the natural radiation of bananas and potassium. These particles, which have no mass or charge, are the most powerful infinite phantoms. Whenever they are created, they don't usually interact with matter. Neutrinos travel through every square centimeter of our bodies around 100 billion times each second, but they are so weak that we can't feel them. Because of this mysterious quality, they were called ghost particles. Researchers have been searching for them since 1956 when they were first seen dashing out of an atomic reactor. In 2021, physicists found the marks of 6 neutrinos, but it took them another 2 years to gather enough evidence to show that these mysterious particles were truly the task. The research will continue to gather data until the end of 2025. According to James Boyd, a particle physicist at CERN and co-sponsor for Phaser, ghost particles can show us deep space in ways that other techniques can't. These very high-energy neutrinos at the LHC are essential for understanding particle astronomy discoveries. Scientists hope to find more of these ghost neutrinos and settle physics questions we haven't explored yet. A lot of researchers are very eager to see what CERN discovers next and what those findings will mean for the future of science. Thanks for watching another episode. Click on the video on your screen to see more like this one that will take your breath away.